In this lesson, we'll be looking at polygons. We'll be specifically looking at their angles. We'll talk about interior angles inside a polygon and their exterior angle measures of a polygon. So one of the things to think about is a triangle. We've already done this before, where a triangle, we know the interior angles, if we add them all up, then they will equal 180 degrees. So as we look at polygons that are going to be bigger, one of the ways you can think about it is splitting that polygon up into additional triangles. So this shape that we have over here, it's a pentagon. As you can see, they use these red lines in order to draw out additional triangles. So essentially in this one, I would have 180 degrees in this first triangle, 180 degrees in the second and third. So if I do 180 times 3, it would give me the measure of my interior angles. And this is a formula. So if we think about the formula for it, like I said, you can either break it up in triangles or you can use the formula. But it's just you add up all your angles inside would equal the number of your sides. So this n is the number of sides minus 2 times 180 degrees. So in the example that we have here, we have n is 6, so I would have 6 minus 2 instead of n, if I plug it in, times 180. So then 6 minus 2 gives me 4, so I'd have 4 times 180 degrees, which would give me 720 degrees. I'm sorry, that 7 didn't come out very well. 720. So in this example 1, I just need to count up my sides and then use that same formula. So in this shape, I have 1, 2, 3, 4, 5, 6, 7, 8-sided figure. So my n is equal to 8. So all I do is use my formula. So I have n minus 2 times 180. So my n is 8, so I have 8 minus 2 times 180 degrees. 8 minus 2 gives me 6 times 180, which gives me 1080 degrees. Like I said, you can also split this up into triangles. So if I start at one vertex and just keep connecting it to all the other ones, I can split it up into triangles. And so here you can see I would have 1, 2, 3, 4, 5, 6 triangles, which essentially leads me into this step where I have 6 times each of those triangles has 180 degrees. It would get me the same answer. Another type of problem we find whenever we are looking into these is the opposite. Instead of having the number of sides, we may want to find the number of sides given a certain amount of degree measures. So in this one, we have the sum of the measure of the interior angles of a polygon is 900 degrees. It wants us to classify the polygon by the number of sides. So think about our formula. Our n minus 2 times 180 would equal our degree measure, or our interior angle sum. So in this case, our interior angle sum, it told us, is 900. And so I don't know n. I'm going to leave my variable for n, and then I'm just going to solve. So in this case, I'm going to go ahead and distribute. I just multiply inside my parentheses, so I get 180n minus 360 equals 900. I'm going to add 360 to both sides. To where I get 180n is equal to 1,260. To get n by itself, I need to divide by 180. And so I get n is equal to 7. In my problem, though, it told me to classify it, so a shape that has 7 sides is called a heptagon. So that would be my answer for this problem. In this example, we're just kind of doing the same thing, but now we have a variable involved. So I can still think about my formula. So I have like my interior angles sum is equal to 180 times n minus 2. My inter-angle sum, though, here I'm going to need to add up every single one of my angles. So I have 108 degrees, plus I have 121, and I'm just going to cross them out as I go to make sure I don't do one of them twice. I have plus x and plus 59 would still equal 180 times n minus 2. So I just need to simplify both sides. So on the left, if I add up all my like terms, all these numbers, I get x plus 288. And on the right side, I'm going to go ahead and distribute it again. So I get 180n minus 360. If you notice when we get to here, though, we have two variables. Okay, but I do know my n. My x is what I'm solving for. My n, remember, is just my number of sides. So in this shape, I have 1, 2, 3, 4 sides. It's a quadrilateral. So I can plug that in for n. So I have x plus 288 is equal to 180 times n. And I'm going to have to erase some of this so I can write it down on the same screen. So up here I'm going to have x plus 288 equals 180 times n, which now is 180 times 4, minus 360. 180 times 4 gives me 720. So I have 720 minus 360 on the right. I still have x plus 288 on the left. I'm going to leave that still to where I need to do my 720 minus 360, which gives me 360. To get x by itself, I need to subtract. This is just your algebra skills again. So I end up getting that x is 72. That would be my answer. Once again, this is just setting it up. I need to be able to know my formula that all my interior angles add up to equal 180 times n minus 2, and then the rest of it is just algebra, solving with algebra. In this slide, this is something that you need to have in your notes, so be sure you write it down. We have an equilateral polygon, which tells us that all sides are congruent. We have equal angular, which tells us all angles are congruent on the interior. And then we have a regular, which says both of them. Okay, so equilateral tells us that all sides are congruent, just like an equilateral triangle. Equal angular tells us all angles are congruent, and a regular polygon is every time that we have both of them. We have all angles are the same size and all sides are the same. So if we move on to example 4, we have a little bit of a different type of problem here. We have a home plate for a baseball field shown. It asks us, is the polygon regular? Okay, so first, I know 3 angles are 90 degrees. I have these right angles here. And so I need to find out if these other 2 are going to be 90 as well. Well, my figure is a pentagon, so that means I can determine how many degree measures is in the interior by doing 180 times n minus 2. In this case, my n is 5, so I get 5 minus 2. So I get 180 times 3, which gives me 540 degrees. And then I can just look at my other angles. So I have 3 that are 90, because right now, if this would be equal to, I have 3 degree measures that are 90 degrees, plus I have 2 of an unknown size. Okay, so if I solve this, 3 times 90 is going to give me 270, still plus 2x. Like I said, all I'm doing is I'm terming these 2 angles as x here. I'm going to solve, so I'm going to subtract 270 from both sides, which gives me 270 left on the left is equal to 2x. If I divide by 2, I get that x is 135. And so it asks, is the polygon regular? Explain your reasoning. The reasoning would be, it's going to be no, because our angles are not all the same size, so there's no way that it can be regular. It asks for the measure of angles C and D. I found what those measures were, so both of these, measure of angle C would equal 135, and the measure of angle E would equal 135. And then the last thing we need to cover on polygons is the exterior angle. So we talked about interior angles. It depends on how many sides they have, of how many degree measures are inside of that angle, that polygon. Okay, but when we have exterior angles, it's always 360 degrees. Okay, no matter what, no matter if I have a 20gon, it's going to be 360 degrees on my exterior angles. So one thing to remember on exterior angles, it's kind of when I extend the side in the same direction on my shape. So as you can see here, they extended it this direction, then they kept going around it in a clockwise motion. And so they chose the angle on the inside there every single time. And so when I add all those up, I get 360 degrees. No matter what, again, no matter what size, what shape I have, as long as it is a convex polygon, then it is going to be 360 degrees. So in this problem that I have, it says find the value of x. Well, these are all of my exterior angles, so all I do to solve this is I add them up and I equal them to 360. So I have my 2x plus 89 plus 67 plus x would give me 360. I'm going to combine my like terms, so I get 2x plus x gives me 3x. I have 89 plus 67, which gives me 156, is equal to 360. So to keep solving, I subtract 156 from both sides. So I get 3x is equal to 204, divided by my 3 on both sides. So I get x is equal to 68. That's all it asks for, so that would be my answer. In this last example, we have a trampoline. It says it's shaped like a dodecagon. It says to find the measure of each interior angle and find the measure of each exterior angle. So first I'm going to look at my sides. You can either count your sides, or if you know that a dodecagon is 12-sided. So the measure of each interior angle is going to be 180 times n minus 2. And then this would tell me how many degree measures are inside total. If I want to know what the measure is of each one, I need to divide that total by the total number of angles I have inside, which is going to be 12. Okay, so I'm just going to sub in there. I have, instead of n, I should have 12. And then I'm going to end up dividing it by 12. So here I have 180 times 10 divided by 12. If I keep going and I solve this out, I end up getting 150. Okay, again, I do my same formula to find out how many degree measures there are inside total, which is the 180 times n minus 2, and then I divide it by my number of angles, okay, in which case this is going to be 12 angles. Then it asks for the measure of each exterior angle. So my exterior, if I think about this extending all the way around in the same direction, I'd have to go clockwise the whole time. It wants to know what's the degree measure of all those exterior angles. Okay, well, we know the total is going to be 360 degrees. But it wants to know if I mark each one of these angles individually, so I have 1, 2, 3, and if I go all the way around, it wants to know what is the degree measure of each of those angles specifically. Well, since it's regular, they're all going to be the same. And so all I have to do is just divide my total by how many there are. So if I know that it's 360, I just divide it by 12, in which I get 30. So my exterior angles are all going to be 30 degrees.